So for further examples, let's take a look at some problem from these past questions. They say that we are given a problem like this. If alpha and beta are root of the equation roots of the equation px squared plus qx plus r equal to 0, and p is not equal to 0. It's a good condition. P is not equal to 0. They now say find alpha square beta plus beta square alpha. You can see, if you look at this problem, we don't have a standard formula. There's no standard formula for alpha square beta, right? We only have a formula for alpha plus beta if it's in this condition, and we have alpha beta, and the other one we derived so far. So it's straightforward. The first thing you need to do, don't forget, find out your alpha plus beta as well, your alpha beta. Now, if I go back to that problem, let's find out our ABC first. You see they use alphabet here, which is even more interesting. So here, this is my A, this is my B, and this is my C. So here, A is equal to P, B is equal to Q, and C is equal to R. Now, first question out. Okay, the question we are asked to just one question. They say we are asked to find alpha square beta plus beta square alpha. Just factorize it. If you check the two sides, what do we have in common? You can see alpha is common to this side as well. Then we also have a beta. If I factor that one out, what are we going to have left here? Here will remain alpha now, because this is alpha square, right? Just like this, alpha square beta over alpha beta. If beta cancel beta, alpha in alpha square, we have alpha. Can you see? So for the second one, I have beta square alpha over alpha beta. I factor out. If alpha cancel alpha, you can see we are going to have alpha, and we are going to have beta here. So you can see we have already made the problem so much easy for us to solve. Now our alpha beta. So recall that our alpha beta is nothing but minus b over a, and our alpha plus beta is nothing but minus b over a, and our alpha beta is c over a. So from here, I can find them out. My b is q here, and my a is p, right? So here too, my c is r, and my a is p. Let's just substitute the two values. We can even start it from here. Alpha beta is the same thing as c over a. Alpha plus beta is minus b over a. So c here is r over a is p, bracket of minus b is q, a is still remain as p. So you can open the bracket of this one. R times minus q, we can have minus qr, p times p, you are going to have p square. Either they bring the form of alphabet. Let's see another problem. They said given that x squared plus 5x plus 6 is equal to 0, they say find root of figure 1 alpha plus beta, root of figure 2 alpha beta, root of figure 3, or let's say root of figure 3. They say find the quadratic equations of A alpha comma beta, B 2 alpha plus 3 beta, comma 3 alpha plus 2 beta. So let's just take this one for example. Now, so from the problem, I will find my A, I will find my B as well, I will find my C. Now from these questions, I have we have x squared plus 5x plus 6 equal to 0. So from here, I know my A. the same way of why we are finding it. A is 1 here, our B is 5, and our C is 6. So the first thing we have to find alpha plus beta. Alpha plus beta is minus B over A, right? So now if I go back to that problem, I can have this one to be minus B is 5 and A is 1. So that's going to be minus 5. Then the second one, we have to find alpha beta. If we have been told I need them in these all these problems. So alpha beta, we have it to be C over A. Our C here is 6 and our A is the remaining as 1. So here we have 6. Now we have to find another equation of alpha beta, 2 alpha plus beta. You see this one? Let's write out the answer we got now so that we note it down. Our alpha plus beta is minus 5. Alpha beta is 6. Now we have to find, okay, let me just note down this one. We have to find alpha beta. You see, we don't have a formula for ordinary alpha. Note, it's not alpha beta, it's alpha comma beta. You don't need to confuse yourself. You just have to follow the same process. That means you recall this formula, the one we use, so now we can find the root. You know, we use one formula like this, x squared minus alpha plus beta of x plus alpha beta equal to 0. So here you can see this is the sum and this is the product. So this is the one I will use here. So that means that to solve this problem, I will find the sum. At the same time, I will find its product. So for the first question, we have to find alpha comma beta. You know, it's not the same thing as alpha beta, right? Very good. So I can just say let alpha to be alpha, let beta to be beta, because I'm trying to find the sum and I want to find the product. So, you know, if I want to find the sum simply means alpha plus beta, right? So my alpha plus beta here, I've gotten that one to be minus 5. You can see this one is straightforward. We are coming back to a problem that is going to be more difficult to solve, but it's very simple. Now, for the product, I want to find alpha beta. Since my alpha is alpha, my beta is also beta. So we got our alpha beta to be 6. Now we can now go back and substitute back to our formula. Recall that we have x squared minus alpha plus beta of x plus alpha beta equal to 0. So here I've gotten the sum to be minus 5. I got the product to be 6. So let's substitute the 2. And we have x squared sum is minus 5 of x. Product is 6 is equal to 0. So minus, that's going to be plus. That's our x squared plus 5x plus 6 is equal to 0. Now, let's look at the second problem. We have to find 2 alpha plus beta, comma, 3 alpha plus, you can see there's no formula you can use here. It's still the same thing. Just say let alpha to be 2 alpha plus 3 beta, the first one, and let your beta to be the second one, which is 3 alpha plus 2 beta. You find the sum at the same time, you find the product. If I want to find the sum, you know, sum simply means alpha plus beta. Cool? So now, my alpha now is this, and my beta now is just substitute. You know, the first one you can see there's no difference. The reason is alpha is the same thing as alpha, beta is the same thing as beta, but now you can see it's different. I will let the alpha to be the first one, we let the beta to be the second one. So now I can go further. So here now I can have my alpha now is this. I can have 2 alpha plus 3 beta plus my beta now is 3 alpha plus 2 beta. You can see now if you add them 2 alpha plus 3 alpha, you can have that one to be what? That one to be 5 alpha plus 5 beta. If I factorize 5 alpha plus beta, you can see I have alpha beta and alpha plus beta. That one is as usual minus b over a, which we have gotten it already. We have that one to be I think we have alpha plus beta to be 5, and we have, okay, from the problem, just quickly write it here. We have x squared plus 5x plus 6 equal to 0. We said alpha plus beta is minus b over a, that is minus 5, yeah, and alpha beta is 6. So I can substitute it now. I can have this one to be 5, bracket of this one is minus 5. So that I'm going to give us minus 25. You can see straightforward. So we have gotten the sum. The next now, it remains the product. I want to find the product. For the product, I want to find alpha beta. You know, this is my alpha. My alpha is 2 alpha plus 3 beta. And so alpha beta is 3 alpha plus 2 beta. So a simple expansion. 2 alpha times 3 alpha. Of course, you are going to have 6 alpha square. We are expanding now. 2 alpha times 2 beta. And we have 4 alpha beta. 3 beta times 3 alpha. We are going to have 9 alpha beta. The last one. 3 beta times 2 this, and we have it to be 6 beta square. We just expand, just a simple expansion. The first one times first one, 2 alpha times 3 alpha, we have it as 6 alpha squared. 2 times 2 here, we are going to have 4 alpha times beta, we have alpha beta. 3 times 3, we have 9 beta times alpha, we have alpha beta. 3 times 2, we have 6 beta times beta, we have beta square. So now from here, let me make use of this place. So now I can just go now, substitute my value, or rearrange them, rearrange the term. I can have that one, the product now to be, so the product that we have now, we have it to be, let's arrange this one as well. We have 6 alpha square plus 6 beta squared plus 4 alpha beta plus 9 alpha beta. Of course, we are going to have 13 alpha beta. So now we can see something is common here. If I factor it, I can have this one to be 6 bracket of alpha square plus beta square, right? So after that, so we can have this one to be plus 13 alpha beta. Now, you know, we have a formula for this one. If you recall, we have a standard formula for alpha square plus beta square. So that's going to be 6. This is the same thing as alpha plus beta all square minus 2 alpha beta, then plus 13 alpha beta. You know, I did not add this one to this because this one have 6 here. So now let's substitute. We have our alpha beta to be 6 and alpha beta to be minus 5. So by here, this one we have 6 alpha beta, alpha plus beta, we have it to be minus 5. That's going to be minus 5 square minus 2. Alpha beta is 6 plus now 13. Alpha beta again is still remain as 6. So now we have 6 over minus 5 square. That one simply means minus 5 times minus 5. You know, minus times minus 5, that's going to be positive. And we have 5 times 5, that's going to be 25. 2 times 6, we are going to have 12 plus 13 times 6, that's going to be 13 times 6, that's going to be 78. The 78 here. So let's finish the one we have in the bracket so that we can evaluate the one we have in the bracket here. We have 6, 25 minus 12, that's going to be 13. We have 13 here, then we have plus 70 what? 78. You know, when we have a bracket simply means multiplication. That is, you are going to find the 6 multiplied by 13 here. Just like what we did earlier here. We're very lucky here. This is 25 minus 12, we have 13. So we can see when we multiply 6 times 13 the other time, we have it to be 78 plus also 78. So 78 plus 78, that's going to give us 156. You can see we got the sum as well. We got the product. We get our sum to be, we have to be minus 25, right? So now we can substitute it back to that equation. Recall that we have x squared minus alpha plus beta of x plus alpha beta equal to 0. So now I can substitute the two now. I can have this one to be x squared. I got my sum to be 25x. I have this one to be 156 is equal to 0. So let's solve another more problem. Let's solve another more problem. Now we can make use of that one. That is, how can we find, let's look at this past Q as well. Is one particular interesting question here, very interesting questions. They say that let's look at this one. This one is very interesting questions. They said if alpha and beta are roots of the equation, the root of the equation 2x squared plus 7x minus 3 equal to 0, determine the equation whose root alpha plus 5 over beta and beta plus 5 over alpha. If you look at this, look at this one. So we are given the options. Well, let's just firstly approach it. So now we can find that one. Either the simple logic of that, or either any other way. Just follow the same process, the same pattern on how we can approach the problem. We are given that alpha plus beta is alpha. We are asked to find this equation given to us. We have 2x squared plus 7x minus 3 is equal to 0, and we are asked to find alpha plus 5 over beta and beta plus 5 over alpha. I will just solve it the same process, the same pattern, the same method. But the thing is, you can see we don't have a standard formula for alpha plus 5 over beta, and we don't have a formula for beta plus 5 over alpha. So that means I need to find the sum. At the same time, I need to find the product. Now, let's first find our alpha plus beta first. From that problem, let's identify out our data. We have 2x squared plus 7x minus 3 equal to 0. As usual, here, A here is 2, B is 7, and C is minus 3. So now, what is the first one? Alpha plus beta. As usual, alpha plus beta is going to be minus B over A. That is minus 7 over 2, right? Because our B is 7 and our A is 2. Then as well, alpha beta is C over A, and that's going to be minus 3 over 2. So we need this one most. Let's put it here. Alpha plus beta. We have it to be minus 7 over 2, and we have alpha beta to be minus 3 over 2. Now, so we are asked to find a root of these equations, alpha plus 5 over beta and beta plus 5 over alpha. You can see you don't have a standard formula for this one. Even if you take the XCM, you can't get the formula for that. So that means we have to use the other one I use. We find the sum. I will find the product by saying let alpha to be alpha plus 5 over beta, and let beta to be beta plus 5 over alpha. So I will find the sum and I will find the product as well, because we all have a particular questions that relate to the same thing. So if I want to find the sum, if I want to find the sum simply means alpha plus beta, right? So this is my alpha. I'll just substitute. Alpha is alpha plus 5 over beta. Beta is what do we have there? We have beta plus 5 over alpha. Now, here I can have the sum to be this alpha plus beta. That one can we just arrange this one? We can arrange them to make it more easier. Here, if I arrange this term, if I arrange them, we can have alpha plus beta plus 5 over alpha plus 5 over beta, just to make it more easier. Alpha plus beta plus 5 over alpha plus 5 over beta. So now I can have this one to be, can we take the XM of these two? You can see what we have there is alpha beta. If you like, you can take the XM, or if you like, you can take the XM of all of them. But to make it more easier, you can have alpha plus beta plus this one is going to be alpha beta. That's going to give us 5 alpha plus like this. Let me explain this one very well. Alpha in alpha beta. This one we cancel this. Remove beta. That's going to be 5 beta plus beta in this. And we have alpha 5 times. We are going to have 5 alpha. So let's substitute our alpha plus beta here. we have it to be minus 7 over 2, right? This is it. Alpha plus beta is minus 7 over 2 plus, you can see 5 is common here. If I factor it out, we have 5 bracket of, it remain, you know, I told you, if I have beta plus alpha, of course, it's the same thing as alpha plus beta. Now, I have my alpha plus beta again to be minus 7 over 2. Alpha beta, we have that one to be minus 3 over 2. So here I can have minus 7 over 2. If I open the bracket of this one, if I open the bracket, this times this, we can have that one to be minus 35 over 2 divided by minus 3 over 2, the one we have in the bracket. So this one can just be minus 7 over 2 plus minus 35 over 2 times 2 over minus 3. So the same way, minus times minus, minus times minus, that one can give us plus. So can I just write it here? That's going to be minus 7 over 2. Minus times minus is plus, so you can see 2 can cancel 2 here, right? So that means we are going to have that one to be 35 all divided by 3. Look at it here. Minus 3, 35 over 2. If I have division between two fractions, you're going to change to multiplication. We have times 2 over 3. So 2 cancel 2. Minus times minus, we have plus. Then we have 35 over 3 here. So if I take the LCM, LCM of 2 and 3, that's going to be 6, right? 2 in 6, that's going to give us 3. 3 times 7, and we have minus 21. 3 in 6, we have 2. 2 times 35, that one is 70, right? So we have 70 here. Then 70 minus 21, just a simple arithmetic. 10 minus 1. To make it more easier, that's why I'm using this method. 10 minus 1, we have 9. You can see what we have left is 6. 6 minus 2, and we have 4. So that means here you are going to have 49 over 6. That means for the sum now we have 49 over 6. You go further by finding your product as well. Let's just write the sum here. Let's write the sum here. That is what we get for the sum. We have the sum to be 49 over 6. So now, the next thing now is to find our product. Product as well, that one means, product means we should find alpha beta, and we have gotten that one already. We have our alpha is alpha plus 5 over beta. Dot second one is beta plus 5 over alpha. So let's expand. It's just a simple expansion. Alpha times beta, we have alpha beta. Alpha times 5 over alpha, 5 alpha can cancel alpha here. We are going to be left with 5. How? Alpha times 5 over alpha. Alpha cancel alpha, then we have 5. Second one now, 5 over beta times beta. Of course, we are going to have 5 because beta will cancel beta. 5 over beta times 5 over alpha. We are going to have 25 over alpha beta. Now, this one I can have this one to be alpha beta plus 5 plus 5. We have 10. This is 25 over alpha what? Alpha beta. Now, the next thing now is for me to take, we know the result of this. At the same time, we know the result of this. Just substitute, simple substitutions. So alpha beta, we have to be minus 3 over 2 plus 10 plus 25 divided by our alpha beta here is minus 3 over what? Over 2. So now, from here, we can just make a simple assumption here, or we can just make a simple demarcation. And if you like, even from here, you can even take your LCM. If you take your LCM, it's still going to be the same. How? This is what I'm saying. From here, I can find my LCM. What's going to be my LCM? My LCM here is going to be alpha beta, right? Alpha, is over 1. This over 1 as well. This in this we have 1 times this we have alpha beta all square. 1 in alpha beta, we have alpha beta times 10, and we have 10 alpha beta. So this in this we have 1 times this we have 25. Anyhow you do it, you are going to get the same result. So I know my alpha plus beta. Alpha beta is minus 3 over 2 all squared. 10 alpha beta is again is minus 3 over 2, then plus 25. You can see all divided by alpha beta, and alpha beta is also minus 3 over 2. So now, if I square this one, you know that is going to be 9 over 4. That is minus 3 times minus 3, that is 4. 2 times 2, that is minus 3 times minus 3, that is 9. 2 times 2, that is 4. Then we have minus this times 6. We are going to have 30 over 2 plus 25 divided by minus 3 over 2. We use to make use of this place, since we have gotten the questions already. Now, if I like, I can find the XM of this one. XM of this is going to be 4. 4 and 4, that's going to be 1. And we have 9 left here. 2 and 4, we have 2. 2 times 30, that's going to give us 60. Plus, I can have this one to be 1 and 4 now. That's going to be 4, right? So 4 times 25, we are going to have 100 divided by minus 3 over 2. So just do this simple arithmetic here as well. 100 minus 60, that's going to be 40, right? Then 40 and 9, you can see 10, that is 9, that is 1 here. This remain 3, that's 31. It's 31 over 4. Now, if you have multiplication between two fractions, it normally change to what? If you have division between two fractions, no, law of reciprocal. If you change to multiplication, that means that we have times minus 2 over 3. Now, you can see 2 here, 1, 2 here is going to give us 2, right? This is going to remain 31 over 6, together with the minus that we have in that particular. Even in the options, we have like in the question itself, we have like many options there that can we are able to factor out our values. Now we got the sum as well. We got the product. So now the next thing now is to check whether our result is, just substitute back to that problem. Since you have your alpha beta and you have your alpha, the same method. Either we have equations related to any of this approach, either to find the, you can even say find your alpha plus beta over anyone you ask to find, just substitute back to that one, and you make use of that that method that we use using this formula. It's x squared minus alpha plus beta of x plus alpha beta equal to 0. Since you have the sum, you have the product, you just substitute and find your result. So that's all we have for using alpha beta equations. So thanks for listening to Made Easy Academia. So you can be able to have an access to our videos and the material we are using. So please don't forget to subscribe, likes, and share our videos. So may God continue to bless you. Thanks for watching.